Okay, today we're going to talk about 3 more shortcuts for proving triangles are congruent. And those 3 shortcuts are ASA, AAS, and HL. So again, we'll be talking about these shortcuts and we'll do the proofs in class. And just to reiterate, the 2 shortcuts that you should be pretty familiar with are SSS and SAS. We've already talked about those. And SSS, remember, is where we have, we know that 3 different sets of congruent sides. 3 different sets of corresponding sides are congruent. And for SAS, we know about 2 sets of sides, and we know that that included angle is congruent. So if we know something like this or something like this in both triangles, then those triangles will be congruent to each other. Okay. Today we're going to talk about, if you notice, this one has 3 S's and this one has 2 S's. So today we're going to talk about what happens if we just have 1 S. And in that case, what happens if we only know information about one side, and that's going to be, we're either going to use ASA or AAS. So the first shortcut is ASA, and ASA looks a lot like SAS. Remember, SAS is important because this angle is included. It's in between those 2 S's. This, in ASA, this S is called an included side because it's in between those 2 angles. So the first vocab word that you'll want to take note of is called an included side. Again, if we know, if we want to talk about these 2 angles, angle P and angle Q, side length PQ is going to be the included side. It's in between those 2 angles that we're talking about. So ASA, I'm sure as you can take a guess at, if we had 2 triangles, and I knew that one set of angles were congruent, and a second set of angles were congruent to each other, that side that's in between, that's included, that's touching both of those angles would have to be these ones. If we have something that looks like that, then those triangles would be congruent to each other. All right, that's the first shortcut. And basically, so here's an example. Again, also make sure you look out for the reflexive POC to find missing side lengths. So we have 2 sets of congruent angles, and we have this included side. So yes, these triangles would be congruent by ASA. Also, besides just looking for the reflexive POC, I want you guys to look out for parallel lines. Whenever you see parallel lines, we're going to think alternate interior angles. Now, 2 things about parallel lines, besides alternate interior angles, because if you have alternate interior angles, those are the ones that kind of look like the Z. Also, I want you to remember that it's touching those parallel lines. So if we have alternate interior angles, that means we have congruent angles. But some people mistake parallel lines for congruent sides. Parallel line does not mean that they're congruent. All right, so in this example, determine if you can use ASA to prove that triangle NKL is this left-hand triangle, is congruent to LMN, triangle LMN. So are these 2 triangles congruent to each other? Well, we have parallel lines, so that means we can have alternate interior angles. So we know this angle is congruent to this angle. Okay, and then that's about it. And let's see, we have a congruent side. So we have an angle and we have a side, and we don't have enough information. This does not mean that those sides are congruent, so we do not have enough information. Now, let's say, for example, I wanted to add more information. Let's say I told you that this angle was congruent to this angle because these sides were parallel. Then, by angle, side, angle, those triangles would be congruent. So I needed enough information. I needed to know that these lines were parallel, and then you can conclude that those triangles are congruent by ASA. Okay, so make sure you're aware of parallel lines. The second shortcut we can skip that one, is angle, angle, side. Now, if we look at this one, determine if, actually we'll come back to it, yeah. Determine if you can use ASA to prove that these triangles are congruent. We have an angle, angle, and then we have this missing reflexive POC. We know that the sides congruent to each other. Now, these triangles are not congruent by ASA, because if we read from tick mark to tick mark, again, you can't skip around. So usually I go 1 tick mark to 2 tick marks, right? So if I read angle, angle, I'm stuck. There's nothing about this page, about this side. So I'm going to go in the reverse order this time, even though I don't like to do that. So I'm going from 2 tick marks angle to 1 tick mark angle, and then to this congruence side. So this is AAS. This side is not included. So although I cannot use ASA to prove these triangles are congruent, these triangles still are congruent by our other shortcut called AAS. So an angle side, this side is not included. It's only touching one of the angles. So an angle side, I'm going to scroll down a little bit. An angle side, the side is not included. Not included. But these triangles are still going to be congruent to each other, and I can again prove it to you guys in class. Sides are not included, but it's still going to work out. So that's the only difference between AAS and ASA. All right. So remember, to recap, we already know about SSS. We know about SAS. So this is 3 sides are congruent, 2 sides are congruent. We know that ASA works. That's 2 sides, or 1 side is congruent, right? 1 set of sides. And we know AAS. That's another. Only 1 set of sides are congruent. And then let's see if we reverse this. Is there any other way for us to put this S? What if we did SAA? We have S in the middle, we have S at the back, we have S in the front. These are exactly the same. So pretty much if you know anything about 1 side and 2 angles, those triangles will be congruent. The only difficulty part is distinguishing between AAS and ASA. And that's hard for some people. And you just need to remember that in ASA, the side is included. It's touching both of those angles that we're talking about. In AAS, the side is only touching one of those congruent angles. So for example, again, I still have 2 sets of congruent angles, but this time the side's only touching one of the congruent angles. So this is one possibility. If I have a picture like this, angle, side, then those triangles would be congruent. Another possibility, again, if I drew those same triangles and I have those same angles, if I knew not about those sides, but I knew about this side, again, this one side is touching one of the angles, so yes, those triangles would be congruent by AAS. So there's a lot of flexibility for AAS because since it doesn't really matter where the side's only touching one of the angles. Okay, and again, that proves triangles are congruent. The very last one is called HL. Okay, so we've talked about SSS, SAS, AAS, and ASA. Those are a lot. Now, all of a sudden, they throw in an HL at you. What the heck is going on? Well, if you remember, HL stands for hypotenuse leg. And if you remember from earlier on in the year, hypotenuse talks specifically about right triangles. So we are only talking about right triangles here. That's the only type of right triangles that this works for. So if we have a right triangle, the hypotenuse is across from the right angle, and then the legs are the other sides, and it doesn't really matter. It doesn't really matter. They're both called legs. Okay, so for hypotenuse leg congruence, the last shortcut that we're talking about is if we have 2 right triangles, excuse me. If we have 2 right triangles, and I know that the hypotenuse is congruent, the hypotenuse, I guess, are congruent to each other, and that one of the other legs are congruent, then these triangles are going to be congruent. Now, there's a reason they use hypotenuse leg and not the S's and A's, because if you spelled this out with S's and A's, we would get a bad word. So that's why they use HL instead of the S's and the A's. And to let you know that we're only talking about right triangles and not any other type of triangle does it work for. It's only right triangles. And then, sometimes they like to, really HL works, LL works, LH works. There's a bunch of different things you can do because of Pythagorean's theorem. Because let's say, for instance, that you don't know that you can use Pythagorean's theorem if you know that this side is 3 and this side is 3 and this side is 5 and this side is 5. You could do Pythagorean's theorem and figure out what this other leg is just fine, and then you'd have SSS. So hypotenuse leg is something you can use only for right triangles, but you have a lot of flexibility with HL because of Pythagorean's theorem, again, because you have right triangles. So you can figure out all the sides and use SSS if you want to. Okay, so last example and then we're done. Determine if you can use the HL congruence theorem to prove the triangles are congruent. If not, tell what else you would need to know. So for A, are these triangles congruent? Well, let's see. We have an implied reflexive clock, so we have another tick mark, and we have this one's a right angle, so this one's a right angle. So I have two right triangles, and we have the hypotenuse are congruent to each other, and a leg is congruent to each other. So we have a hypotenuse and a leg. So yes, they are congruent to each other. So you guys, this one, a lot of people think that they are congruent because they look like it, but we have a right angle, sweet. We have a side, sweet, but I don't know anything about the hypotenuse, and I don't know anything about this leg. They don't tell us, so no, this would not be congruent. I would need to know that the hypotenuse are congruent to each other. The hypotenuses are congruent to each other in order to use HL. Fun fact of the video. You can beat brain freeze by sticking your tongue to the roof of your mouth. And if you check on your calendar, you don't have to do anything out of the book, but you do need to go to Khan Academy, and you need to do, sorry, we'll do proofs tomorrow. You need to do Khan Academy, and you need to do, let's see, congruent triangles 2. No, wait. Oh, I can't remember. Sorry. Look on your calendar. Sorry. I think you just have to do a Khan Academy stuff. All right. Thanks, guys. Bahaha. I was right. Okay. Sorry. So on your calendar, it says, I misspelled calendar. Sorry. On your calendar, it says on Khan Academy, you need to do congruent triangles, congruency postulates. Bahaha. All right. So you're going to type in congruency postulates into Khan practice and do those. Sorry.